Hello everyone, welcome to the new video on Gradients Plus. In this video, I am going to explain how you would have scored 90 plus percentile in quant section of CAT 2020 slot 2. It was considered as one of the toughest slot for quant section, and to score 90 percentile in this section, you just had to solve 9 questions correctly in 40 minutes. So that's 9 questions in 40 minutes. So this is the bare minimum you had to do in order to clear the sectional cutoff for quants in CAT 2020 slot 2. In this video, I am going to show you bare minimum thing to do to clear the sectional cutoffs, and also I will solve the questions for you guys. So if you are new to CAT, you would get an idea about picking the right questions, and if you are a repeater, this might help you in your next attempt. So let's get started. The first question that I picked was this. So if you carefully look at the equation says that x square minus 5x plus 7 raised to x plus 1 is equal to 1. Now how can we get 1? First is anything raised to 0 is 1, or second, 1 raised to anything is equal to 1. Now if we equate this equation with our first equation, can I get x plus 1 is equal to 0? Therefore x is equal to minus 1. From the second equation, I'll have to equate x square minus 5x plus 7 is equal to 1. So that gives me x square minus 5x plus 6 is equal to 0. So if you split this 6 into 3 into 2, you will get the answers as 3 or 2. So you have 3 or 2 or minus 1. So we have total 3 integers which are satisfying the equality. So your answer to this question is option 3. Let's move on to the next question. So the next question says that how many 4-digit numbers, each greater than 1000, each having all 4 digits distinct, are there with 7 coming before 3? That means 7 has to be to the left hand side of a 3. So this is acceptable, but this is not acceptable. So how many numbers are there? The question is this. Now, first case, let's take 7 at the left extreme. In the second case, let's take 7 at the second step. And in the third, we will take the 7 in the third position. Now you can't place 7 at the rightmost position because it has to come before 3. Now let's focus on the case 1, in which we have possibilities like, so 7 and 3 can come here, 7 is here, 3 can come over here as well, 7 is here, 3 can come over here. So we have 3 possibilities in this first case. So how many ways we can create the number? There is only one possibility, but for 7 to be here, that's why 1. Same goes for the 3. How many digits can come in this place? We have total these many digits. So we have 7 and 3 gone. So we are left with total 8. So 8. And since the digits are distinct, in this position I can have 7 possibilities. So 1 into 8 into 7 is the one way. In the second, also there is only one way of putting 7. So 1 way of putting 3, that's why 1. And there are 8 ways of putting this number, and there are 7 ways of putting this number. And in the third, again we have one way of putting it 7, one way of putting 3, and 8 and 7. So can I say that 56, so 8 7s are 56 into 3. So 168 total number of possibilities for the first case. Now let us look at the second case. Now in the second case, we can have multiple possibilities again. So if 7 is here, 3 can be here. If 7 is here, 3 can be here. Now in this case, in the first position or the leftmost position, you can't have a 0. So your 0 is gone, your 7 and 3 is already gone. That means you are left with 7 possibilities. Now again, there is only one way of putting 7, one way of putting 3, and then there are again 7 possibilities to put this number, because you have to include 0 as well in this way, because you can put 0 at the rightmost position. So it is total 1. So it is total 7 into 1 into 1 into 7. In this case also it will be same, 7 into 1 into 7 into 1. So that will give you about 49 into 2, 98. And talking about the last case, in last case we can have only one possibility, that is 7 and 3. Now how many ways you can put this number? I can't put 0 over here. 7 and 3 is already taken. That means you are left with 7 numbers. And in this position you have to include 0. That means again it is 7. So 7 into 7 into 1 into 1 give you 49. So 49 plus 98 plus 168. So let's quickly add them up. 168 plus 98 plus 49. 8 plus 8 16, 16 plus 9 25, 2 6 8, 8 4 22, 22 and 9 31. So total 415. The answer to this question is 415. Let's jump on to the next question. Once again, an easy question. The question says that two circular tracks T1 and T2 of radii 100 meter and 220 meter at a touch point at A. So let's do one thing. This is the touch point, let's say, and this is the smaller one. Yeah, this is the T1, this is T2, and Ram and Rahim are walking. Ram is walking on T1 and Rahim is walking on T2. Ram's speed is 15 km per hour. So to convert kilometer per hour to meter per second, we just have to multiply by 5 by 18. So 5 into 5 by 18 meter per second, and he is traveling to 5 into 5 by 18 meter per second. Now to answer this question, you just have to find the ratio of time taken by Ram and Rahim. Now how do I do that? Now speed is equal to distance upon time. So time becomes distance upon speed. So for Ram, distance is 2 pi r. So the radii are given, right? The radius is 100 meter and 20 meter. So for Ram, the distance is 2 pi r upon its speed. Speed is 15 into 5 by 18. And Rahim, so Rahim will take 2 pi into 20 divided by 5 into 5 by 18. Now if you divide them, 2 pi will get cancelled. 5 will get cancelled. 5 3s are 18 will get cancelled. So 25s are. So I have got the ratio of time taken by Ram to Rahim as 5:3. Hence the distance travelled by Ram to distance travelled by Rahim is 3:5. So the question they are asking is the number of full rounds that Ram will have to make before he meets Rahim again for the first time. That means after 5th round, Rahim will be at the starting position, and after 3rd round, Ram will also be at the starting position where they will be meeting for the first time. Hence, Ram will make 3 full rounds of the circular track. So 3 is your answer in this case.